Hi, my name is Dr. Tishawn. In this video, we are going to find the derivative of an inverse. I'd like to preface this video with, I have made an algebra video on inverse functions in case you need a review of the properties of inverse functions that we need to use in this video. I'll put the link to that down below. Okay, so here we go. We are going to find the derivative of an inverse function. So our example, ideally, if we can take a function, okay, and we can take the x and y variables, switch the variables around, find the inverse, take the derivative, that's the easiest way, isn't it? Okay, but what if taking the function, switching the variables, what if you can't get the inverse that way? All right, so you can still have an inverse, but what if you can't get the inverse that way? Well, then there's a special formula that we need to use, and we're in a calculus class here, and there's a special formula we need to use to compute that derivative of the inverse. All right, so here's a little explanation, quick little explanation as to where that formula comes from in case you're interested in knowing that, and then we'll learn how to use it. So I'm letting f of x equal a. I'm just going to call it a so I can have those pieces in my answer. So f of x is going to be a. The inverse function is denoted f to the negative 1 of x. That's the how we denote it. Sometimes it's called g of x as well. So when you're reading about it, sometimes they'll tell you in the directions, let g of x equal the inverse of the function f. So we're going to just, those are interchangeable, okay? So g of f of x is equal to x, f of g of x is equal to x. If you have f and g are inverses of each other, then when you do the composition, both ways, plug the function into the inverse, plug the inverse into the function, you will get x, okay? So what we have here, so now we want to go ahead and just taking one side here, and I went ahead and differentiated both sides, okay? So I've differentiated both sides here. So on the left side differentiate, you're going to need to use the chain rule, right? So you're going to have g prime bring down the inside f of x times f prime of x. Use the chain rule on the left, derivative of the outside, leave the inside alone times differentiate the inside. And then on the right side, the derivative of x is 1. All right, and then we're going to just divide both sides by f prime of x. So you have 1 over f prime of x. And then we're going to make substitution. So we're going to call f of x a, okay? And we're going to call our x back here to g of f of x, make our substitution, and f of x is a. So here is a way that you can generate the formula that we're going to need to use to find the derivative of the inverse, okay? So our derivative of the inverse is 1 over the derivative of the function evaluated at the function value of the inverse, okay? So that's what it is in words that we're going to need to do. So we're going to use this as an example. Our function is 1/4 x to the third plus x minus 1. That's what our function is. And so we want to find the derivative of the inverse when x is 3 on the inverse. Now, like I said earlier, y equals, switch the variables, find the inverse, find the derivative, evaluate. That would be nice, but can't find the inverse that way here, okay? So what do you do when you can't find the inverse that way? We have to utilize this formula. All right, so we are going to, let me write this over here. We want the derivative. So this is the inverse. We want the derivative of the inverse when x is 3. So what do we do to get the derivative of the inverse when x is 3? It's going to be 1 over the derivative of the function, okay, evaluated at the function value of the inverse. All right, when x is 3 on the inverse. We want the y coordinate on the inverse when x is 3. So this is what we need. Look at what we need, okay? We need the y coordinate on the inverse when x is 3, and we need the derivative of the function, okay? Let's start with the derivative of the function. We know what the function is, all right? So we know what the function is. I'll rewrite it over here. So our function of x is 1/4 x to the third plus x minus 1. Let's go ahead and get the derivative of the function. Okay, so bring the 3 around front, so you have 3/4 x to the take 1 away from the exponent. The derivative of x is 1, derivative of a constant is 0. There's the derivative of the function, okay? Now we need to plug in a number to the derivative of the function, and we'll do that. We don't know what the number is that we need yet. I'm going to leave a little space so we can compute that, but now we need to figure out what the function value is on the inverse. So how do we do that? Okay, well, there's a property from your inverse functions that we're going to use. So let me write down here. So on your inverse, okay, on your inverse function, we know that x is 3 because we have to evaluate the derivative of the inverse when x is 3. We know that x is 3. We don't know the y coordinate that we need that goes right here. We don't know the y coordinate. So on the inverse, if 3 comma we don't know is on the inverse, then, well, then what's on the function? Then on the function, okay, we don't know comma 3 is on the function, okay? Because AB's on the inverse, then BA is on the function. So if x is 3 on the inverse, then that's the y on the function. So we're going to use this information because we know what the function is. We're going to use this information. We're going to take the function. We're going to plug the y, which is f of x, right? 3 equals 1/4 x to the third plus x minus 1. We're going to plug 3 in for y and solve for x. Once we know x on the function, we're going to know y on the inverse so we can answer our question. All right? We've got some algebra to do, right? So what do we do to get through this algebra? Well, let's go ahead and start by getting rid of the fractions. I'm just going to offer up my solution here. So let's multiply every single term all across both sides of the equal sign. Every single term, let's multiply by 4 because that's going to get rid of the fraction up there up front, give us a coefficient of 1 on the x cubed. So 4 times 3, that gives us 12. Here the 4's cancel, so x to the third plus multiply by 4, so 4x, and then multiply by 4. So we multiplied every single term by 4. All right, and then let's go ahead and get our cubic on one side, 0 on the other. So let's subtract 12 from both sides. Okay, so subtract 12 from both sides. So the left side you have 0. Okay, equals, we have x to the third plus 4x. And then negative 4 minus 12 is minus 16, okay? And then we need to look for some solutions to this cubic, okay? So another algebra, this is something you'll learn back in algebra class. If you have any possible integer solutions, because we kept the coefficient on x to the third is 1, if you have any integer solutions, they would be all the factors of negative 16, wouldn't they? Okay, so I'll write over here, possible integer solutions. Okay, so possible integer solutions would be the factors. What are the factors of negative 16? Plus minus 1, plus or minus 2, plus minus 4, right? 4 times 4 is 16, plus minus 8, because 8 times 2, and then plus minus 16. Okay, so those are your, so we have 10 numbers to try to see if we can find an integer solution here, but that's a lot of numbers. So let's just use some mental math and some reasoning here, okay? All right, 5 of my 10 numbers are negative numbers. If I plug in a negative and cube it, I'd get a negative. 4 times a negative is a negative. So if I take a negative, negative, and negative and add 3 negative numbers together, I'm now getting 0, okay? So we know we can eliminate the negative numbers. 8 and 16 are probably too big, so I just brought my possibilities down to 1, 2, or 4. Okay, so let's try them. Plug in 1, you get 1 plus 4 is 5, and 5 minus 16 is negative 11, so that's not going to work, is it? Okay, then plug in 2, so 2 cubed is 8, and 4 times 2 is 8. 8 plus 8 is 16, 16 minus 16 is 0, there it is, okay? So the x we're looking for, the value we're looking for is 2. That's the one that's going to work here, okay? Just mental math to figure out what number for x we're going to have for our solution here. So, okay, so x is 2. So when y, on my function, when y is 3, x is 2. All right, so we know the 0.23 is on the function. If the 0.23 is on the function, then 3, 2 is on the inverse. Okay, so here, so we've got the number we need over here. We've got the function value. When x is 3 on the inverse, the y coordinate is 2, so we can substitute that in. So the derivative of our inverse is going to be 1 over f prime of 2. So now all we have left to do is plug in 2 to the derivative of the function, okay? We have the derivative of the function right here, so we just need to take the derivative of the function and plug in 2. That gives us 3/4 times 2 squared plus 1. 2 squared is 4. 4's cancel, okay? So you have 3 plus 1 is 4, which means your answer over here, 1 over the derivative of the function at the function value of the inverse, it's going to be 1/4 for your final answer, okay? So this is how formula works, okay? It's what you need to do. It's how you find the pieces. It's how you logically reason through getting all the components that you need for finding the derivative of an inverse function. So anyways, I hope this is going to help with whatever you're doing. It's usually on an AP calculus exam, which is what I teach at the school. So hopefully this helps. Thank you so much for watching. Take care.